Welcome class, and thank you for joining me for the second half of this notes video. In this one, we are continuing 1.6. We're going to transition into considering absolute values and inequalities. So, how we're going to start? This right here, all right? We're going to come back to that. That's an explanation of the strategy I'm going to teach you. So, we're going to come back to those words later. What I want to do is jump right into our first example. So a person's checking account varies between 4,000 and 10,000. So first of all, let's write an absolute value inequality and then graph the inequality on a number line. So the inequality, how we're going to construct it is the same as we discussed in class for the first section. We're going to find the midpoint. Well, what's the midpoint between 4,000 and 10,000? Well, if we add those together, we get 14,000. Halfway is going to be 7,000. So remember, we take that midpoint, we put it inside there. And now, we need to find the distance between that midpoint and each endpoint. Well, that's going to be 3,000. Okay? Now notice, I haven't put a symbol yet. We're going to talk about that. What symbol are we going to get? On a number line, we have 7,000, 6, 5, 4,000, 8, 9, 10,000. As our bank account fluctuates between 4,000 and 10,000. And it says it's in between. It varies between those. So we're getting that middle region of the graph. So this is one way a compound inequality can present itself, can turn out. Now what I want you to realize, that absolute value is being scrunched between those two numbers, all right? So we're talking about the inner region. We want the inequality to be less than or equal to 3,000. It is within that 3,000 of the center point. So to scrunch it in, we use the less than or equal to. All right? So now that we've talked about that, let's continue on to another example. Example 7. Now, just like the first time, when we're talking about these, the first thing we need to do is isolate the absolute value. So, how am I going to isolate it and get it by itself? Well, I'm going to start by adding 5 to both sides. So 3x plus 2 is greater than 17. I added the 5 to both sides. Now, to start with, I'm concerned with the endpoints, all right? So I'm going to construct my two equations, and I'm going to ignore the absolute value for now. I'm just going to say equals, okay? Because I'm concerned with getting the endpoints, and then we'll talk about their behavior, all right? So I constructed my two equations from that with the plus 17 and the minus 17. Now, I solve each one. So I subtract 2 from both sides here. So I get 3x equals 15. Divide by 3, x equals 5. Here I subtract 2. So subtracting from both sides, 3x equals negative 19. And then divide by 3. Now, since we're going to be plotting it, I'm going to take that and actually make a decimal out of it. That is negative 6.3 repeating. So these are my two endpoints for my graph. All right? So when I go to plot these, I'm going to be counting from negative 7 all the way up to 5. 0 and 5. All right, now we're going to plot got these two endpoints. I want you to notice, this is strictly greater than, all right? That means they're going to be open circles. So I have an open circle at 5, and I have an open circle at negative 6.3. Now this one, I want you to notice the difference. The absolute value is greater than that 17, all right? So the absolute value is beyond that number, that radius that we've created, okay? To be greater than that radius, that means this time is going to be going outward, okay? So we get those two endpoints, and we get something that is going out, okay? So what's that telling us? Well, that's telling me that my x is less than or equal to the negative 6.3 repeating, and, oh, sorry, just less than, and it's greater than that 5, all right? So that's what I can get from this. And again, the direction of the inequality tells me if I'm shading the in-between or I'm shading the beyond. Example 8. So here again, I need to isolate my square or my absolute value. So I need to divide both sides by 3/4. So 24 divided by 3/4. When you type this into your calculator, you're dividing both sides by 3/4. Make sure that 3/4 is in parentheses, or that you realize you can multiply by 4/3. Either way, but you need to make sure that you're doing this properly, all right? So try it out in your calculator. Make sure you absolutely get absolute value of x plus 7 is less than or equal to 32. Great opportunity to make sure you're using your calculator right. Make sure you're getting that 32. If you don't, come see me and I will show you how to type it in. So now again, I'm going to break this up into my two equations, and for a moment, I'm going to neglect the inequality. I'm just going to find the endpoints, all right? And then I'm going to use the direction of the inequality to figure out where my shading goes. So here I subtract 7 from both sides. So I get an endpoint at 25. And here, I get an endpoint at negative 39. So those are my two endpoints. So, have 0 in the middle. Down here, I have that negative 39. Up here, I have that 25. Now, I want you to notice my inequality. First of all, is less than or equal to. That or equal to means I'm going to get solid circles. Remember, that's what or equal to means. Now, it's less than or equal to that 32. So it's less than that radius I've created. Well, to be less than that radius, we have to be within that radius. Okay? So here's another example. We're getting that inner range, okay, that inner domain. So what is that telling me? Well, that's telling me ultimately my x is greater than or equal to that negative 39, but less than or equal to that 25. So that is how I can express that inequality. All right, graphically, and then with the true solution. And finally, our last example. So for our last example, we're talking about our tolerance problem. So write an absolute value inequality and a component inequality for the length of 24 feet with a tolerance of 3 inches. So when it gives you that 24 and tolerance of 3, what it's telling you is 24 is that medium. that middle. And the tolerance is how much can it vary? It can vary within 3. So that's the kind of inequality that we're able to construct here. We want 24, we have to be within 3 of that. So that little radius has to be less than or equal to 3. So the cool thing here, our absolute value has already isolated that the absolute value. So our 2 equations, x minus 24 equals 3, x minus 24 equals negative 3. We get our 2 inequalities, or our 2 equations. Add 24 here to get 27. Add 24 here to get 21. So we have our 2 endpoints. Now, with those endpoints, we're going to plot them. So here's 24, 21, 27. Now, first thing to notice, the type of inequality, less than or equal to. Or equal to means at each endpoint it's going to be a filled in circle. Just like that. Now, less than or equal to has to be less than that radius, within that radius. So what does that mean? Well, that means I am bounded inside again. Again, less than that radius. So when I want to write my compound inequality, what I'm seeing is my x is greater than or equal to the lower bound, less than or equal to the upper bound. So that's how I can write as a compound inequality and how I can represent it as a graph. All right, so we're going to do plenty more practice of this during class, but this is all for the notes. So thank you for joining me. You are done with chapter 1 notes. Congratulations. So again, thank you for joining me. We will do more of this in class to get some practice. So wrap up and have a great day.